Assalamualaikum and a very good day to Dr. Nadirul and all. Today our group, which is Group 1, will present our group presentation. So before we start our group presentation, I would like to introduce our group members. Just to know that this is our group members, which is Tila Kraj, Atidayan Anak Lelaki Rabindaran, Padumo Muhammad Abdi Rahman, and me myself, Lailatul Akwanisa binti Muhammad Jasmine. So our topic for presentation today is buffer system in textile industry. So this is the role of buffer systems in textile processing, and I will present about this slide. First is in the role of buffer system, it contains 4 processes, which is dyeing processes, bleaching process, printing process, and finishing process. For the dyeing process, pH influence dye solubility, fiber affinity, and the uniformity of color absorption. Next is bleaching, which is control pH during bleaching to avoid fabric damage. Generally know that bleaching is to eliminate the natural pigments, stain, and impurities from fabric, which to ensure they are the fabric is uniform white and ready for dyeing or printing process. So for the printing is pH control to ensure proper fixation of pigments and dyes and helps to maintain pH in the desired range. Next is finishing process, which is pH stability is crucial during finishing treatments such as softening, and buffers maintain optimal condition the application of finishing agent. So this is the effectiveness of buffer systems in textile industry, and our group just choose both. Our group just choose 2 effectiveness, which is minimize defects and process efficiency. For the minimize defects, pH control to reduce the risk of defects like uneven dyeing and color bleeding. So what is color bleeding? Color bleeding refers to the unwanted transfer of dye from one material to another, which is this often lead during the washing process or even the exposure to moisture or friction. So this phenomenon occurs when dyes are not properly fixed to the fabric or material, so that it will cause the fabric to dissolve and migrate. Some cause of color bleeding is inappropriate washing, material quality, and exposure to moisture. Okay, next one is process efficiency. By stabilizing pH, buffers optimize reaction rates, reducing processing times and chemical usage. Okay, why we need to stabilize the pH during the process efficiency? It is because to protect the fabric integrity, which is to avoid the fiber damage. So, like basically, extreme pH levels, like too acidic or too alkaline, can degrade natural fibers like cotton, wool, or even silk. So, this will reducing the fabric strength. Okay, and the next one, why we have to stabilize the pH, is for the environmental compliance, which is to discharge from textile processing must meet the pH regulations to minimize harm in the water bodies and ecosystem. Like we as humans, basically some of us might have the skin problem. Like example is eczema. So it one of the sensitive skin problem. So we as human, um, especially when we buy product, when we buy fabric, when we buy clothes, we want the high quality product, right? So this is one of the effectiveness to uh, process efficiency. Okay, next is stable pH, which is to prevent over acidification or alkalization to protecting the fibers from degradation. So like I've stated before, which is to protect the the pH, which is to prevent over oxidation, is to minimize harm to water bodies and ecosystem. So for the next slide, I will pass to the next presenter, which is Ilakraj.
Thank you, Raj. So let us continue on my part. I'm gonna talk about textile industry application. So I have two main points, dyeing and finishing. So let us talk about how acid-base reactions are used in the textile industry. First, in dyeing, maintain the right acid-base balance is really important. It ensures that we get the desired colors on the fabric and that the dye sticks properly to the fabric. If the pH isn't controlled, the colors might not come out as expected, or they could fade quickly. So next, the next one is finishing. Finishing is in finishing process, pH control is just as important here. This includes process like softening the fabric, making it easy, it resistant to shrinking, or even preventing wrinkles. If the pH is off during these steps, the quality of the fabric could be affected. So optimization benefits. Now, what are the benefits of controlling pH and optimizing this process? So improved efficiency, we have three points. The first one is improved efficiency, the second one is enhanced quality, and the third one is sustainability. So improved efficiency, when everything is done under the right condition, the process are faster, it's smoother, and the also fewer resources. And the next one is enhanced quality. Enhanced quality, the fabric come out looking and feeling better with long lasting colors and also durability. So the third one is sustainability. Sustainability, by using the right pH levels, industries can reduce waste and minimize environmental impact, making the process eco-friendly. Let us continue. I'm going to talk about cost-effective acid-base neutralization and also environmentally friendly acid-base neutralization. So let us start with cost-effective neutralization. First, we need to calculate the exact amount of base to neutralize acid. For example, if you have 500 liter of hydrochloric acid with a concentration of 0.1 m, that is 50 mole of acid to neutralize it. You will need 50 moles of sodium hydroxide. Using the exact amount avoids wasting chemicals, which also saves money. Now, why do we use sodium hydroxide? Because it is cheap and efficient. Industrial grade sodium hydroxide costs about $0.10 per mole. So for 50 moles, it's just $5. That is really cost effective, especially for large scale process. After that, neutralization, that water that is treated can be reused for things like cleaning or irrigation. This reduces waste and cuts down costs even further, making the process both economical and practical. This method is used a lot of industrial, for example, in factories treating their wastewater, or even in labs handling acid spills. So the next one is environmentally friendly acid-base neutralization. Now let us talk about doing it in an environmentally friendly way. When you neutralize an acid like hydrochloric with sodium hydroxide, the product is a salt and water. These are both harmless and can be safely discharged as long as the pH is within the acceptable range, which is usually between 6 and 9. So in some cases, industries are using baking soda to neutralize acid. This works well, but it releases carbon dioxide gas. If done on a large scale, the carbon dioxide needs to be measured to make sure it doesn't impact air quality. So we also use pH sensors to answer we are neutralizing correctly. These sensors help avoid over neutralizing. So which can make the solution to basic and cause unnecessary waste. This also prevents any harm to the environment. Lastly, industries are moving toward sustainable practice. For example, neutralized water is often reused, and some use alternative neutralizing agents like lime or even natural materials like limestone what's called. So this practice help reduces the overall environmental impact. So that is all my our presentation. Thank you.